Okay, with problems 25 and 26, we just have some strange piecewise function graphs. And we want to purely look at where the limits exist and don't exist from a graphical perspective. We don't even want to know what the expressions are. We want to use the three places where limits don't exist. Once again, those are where the behavior differs from the left and the right, where we have unbounded behavior, and where we have oscillating behavior. So if a limit doesn't exist, it has to not exist due to one of these reasons. So let's take a look at the graph in 25 and 26 and answer those questions. So in problem 25, first of all, we're asked for what is f of 1? And we can see that that is asking for where the value of the function is when x is equal to 1. And that is at y equals 2. When we're talking about the value of the function, then we don't care what's happening to the left and the right. We only care about what the value of the function is at that particular spot. Next, we're asked for the limit as x approaches 1. Well, as we're approaching 1 from the left, we're going up to something like 3.5. And as we're approaching 1 from the right, we're heading to y equals 1. And so this is an example of behavior differing from the left and right. So for part C, we're asked for the value of the function at x equals 4. And here we can see that there is no value of the function there. So we would say undefined, or again, does not exist. So usually when I'm talking about function values, I'll use the word undefined. When I'm talking about limits, I'll use the words does not exist. All right, then finally in part D, we're asked for the limit of f of x as x approaches 4. And so we can see that even though the function is not defined at that point, the behavior does not differ, or the behavior is the same from the left and the right. From the left and the right, both appear to be approaching y equals 2. And so that would be the limit there. So this is another example of evaluating limits graphically. All right, so let's take a look at problem 26, since there were some ideas that didn't come out in problem 25. We're asked for f of negative 2, and we can see that there is a vertical asymptote there, so the value of the function is undefined. Second, we're asked for the limit as x approaches negative 2 of f of x, and there we would say it doesn't exist because of unbounded behavior. And I'll just use the word unbounded right now. Second, we're asked for the value of the function when x is 0, and we can see that that's 4. And so the answer for C would be 4. But then we're asked for the limit of f of x as x approaches 0. And even though the right side is heading for 4, the left side appears to be heading for 1/2. And so we have differing behavior from the left and the right. And I'll just write different behavior. Next, we have f of 2. Well, at 2, or when x is equal to 2, we can see that the function doesn't exist there, or is not defined there, and so we'll write undefined. However, the limit as x approaches 2 of f of x does exist because the behavior is not different from the left and the right. In both cases, they appear to be heading for y equals 1/2. There is not unbounded behavior there, there's no oscillating behavior there, and there's not different behavior there. So we would say that at x equals 2, as x approaches 2, the limit is 1/2. All right, next, what is the value of the function when f is 4? Well, even though we do have unbounded behavior around x equals 4, at x equals 4, the value is clearly 2. So the value of the function at x equals 4 is 2, but the limit of the function as x approaches 4 does not exist because of unbounded behavior. And I hope that's clear then. We can have places where the function does exist, but the limit doesn't exist. We can have places where the limit exists, but the function doesn't exist. And hopefully you can see clearly the difference between the differing behavior from the left and right, what is meant by unbounded behavior, and it's hard in these types of problems to see oscillating behavior, but you can see that in others.